It's kind of mind-blowing when you actually stop and think about how much artificial intelligence is just part of our day-to-day now.
Oh, absolutely.
You know, from the phones in our pockets to, like, the systems deciding what we see online, AI is just everywhere.
It really is.
But it still feels like this, I don't know, mysterious black box humming away in the background for a lot of people.
Totally agree. Yeah, despite all the buzz, really getting the nuts and bolts of AI can feel, well, tricky, like peering inside that black box you mentioned. That's exactly why, for this deep dive, we're digging into AI for Beginners.pdf by Rajamanakam and Tonemuthu.
Exactly. And look, this isn't some super dense academic thing. It's actually a really broad, accessible overview. It covers everything, you know, from the early ideas about intelligent machines way back right up to the apps we use today and even like what might be next.
Yeah.
So our mission today is basically to pull out the most crucial bits, the really interesting stuff, to give you a solid grasp of what AI is all about, without getting totally lost in the technical weeds, you know? Think of it as your quick guide to getting up to speed on AI.
Consider this your shortcut, yeah. We want to give you, the listener, a really clear picture. What is AI, fundamentally? How does it actually work? And maybe most importantly, why does it matter to all of us now?
Okay, so let's start right there. What is AI, like in the simplest terms possible?
Well, at its core, we're talking about teaching machines to think and act in ways that mimic human intelligence.
Right. And sometimes, as the source points out, maybe even do certain things better than humans.
Yeah, exactly. In specific areas, definitely. The key idea is that these machines can tackle tasks that usually need human thinking power.
Like what? Give us some concrete examples.
Sure. Think about facial recognition unlocking your phone, or asking Siri or Alexa a question, or even those movie recommendations you get on Netflix. They seem to know exactly what you want to watch next.
Spookily accurate sometimes.
Right. Or even something really complex like a self-driving car.
Yeah.
That relies massively on AI to see the world and react.
And the really important part here, it's not just following a script, right? Like a fixed set of instructions.
No, not at all.
The source really stresses that AI learns. It learns from data, from experience.
Precisely. That's the core difference.
Yeah.
It's like you show a system thousands and thousands of cat pictures.
Okay.
And eventually it learns to recognize a cat it's never ever seen before.
Yeah.
Based on the patterns it found in all that data.
Got it. So that learning ability is why it's everywhere.
Absolutely. That ability to adapt based on information is what makes it so powerful and, well, pervasive. You bump into it all the time, often without even realizing it.
It's so true. My phone feels like it's half AI now, unlocking with my face, predicting my texts, and social media. That feels like one giant AI playground, right? Content moderation, those ads that seem to read your mind.
Definitely. And online shopping recommendations, your navigation app figuring out traffic.
Yeah.
It's all AI working behind the scenes.
So how does it do that? The source mentions algorithms.
Right. Algorithms are basically the step-by-step instruction. AI uses these algorithms to sift through massive amounts of data, find the patterns hidden in there, and then make decisions based on those patterns.
Like my email sorting spam, or my fitness app suggesting I maybe take more steps tomorrow.
Exactly. Those kinds of things. It's finding patterns and making an informed prediction or suggestion.
So, okay, it's not magic. The author is clear. It's math, it's data, it's programming, building useful tools.
No magic wand involved, no. It's about building helpful tools, exactly. Not quite the sci-fi robot uprising yet.
Huh, not yet. So why should you, our listener, actually care about understanding that?
Well, fundamentally, AI is changing pretty much everything around us. Just having a basic grasp helps you stay informed about the tech shaping our future.
Yeah, and it's not just about the big picture, is it? Knowing a bit about AI can help you make smarter choices about the apps and use every single day. Plus, let's be honest, it's a huge field. Understanding it might even spark an interest, maybe open up career paths you hadn't thought of. It's relevant for everyone, not just the tech whiz.
Definitely. Now, while AI feels super modern, this whole idea of creating intelligent machines, it actually goes way back.
Oh, right. The source mentions that, like ancient myths.
Yeah, exactly. Ancient myths, early philosophers. The fascination isn't new. Humans have been thinking about this for centuries.
But, okay, the actual history of AI as, like, a field of study, that kicks off more recently, right? The 1960s seemed like a big moment.
They were a period of huge optimism. You had early programs like The Logic Theorist and Eliza, that chatbot that could sort of hold a conversation.
I remember reading about Eliza. Kind of creepy, but cool for its time.
Definitely groundbreaking. Yeah. And it fired up a lot of excitement. People really thought, truly intelligent machines were just around the corner.
But then things cooled off. The AI winters.
Yeah, the AI winter happened in the 70s and 80s. It's
Right.
a good reminder the progress isn't always, a straight upward line.
So what caused the freeze? Why did things stall?
Well, a few things. Partly, the early systems just couldn't live up to the massive hype.
Okay.
Plus, computer power back then was, well, pretty limited compared to now. And crucially, they just didn't have the sheer amount of data that modern AI thrives on.
Right. Data is the fuel.
Exactly. So funding dried up, interest waned, AI research kind of went into hibernation for a bit.
But obviously it woke up again. The source talks about a big resurgence. What brought AI back?
Three main drivers, really. First, data, just an explosion of data with the internet and everything going digital. Suddenly, there was tons of stuff for AI to learn from.
Makes sense.
Second, big breakthroughs in algorithms, especially something called deep learning, which gave AI much smarter ways to process all that data.
Okay. Better learning methods.
And third, just raw computing power. Faster chips, specialized processors like GPUs. Suddenly, it was possible to actually train these really complex AI models much faster.
More data, smarter learning, more power. The perfect storm, basically.
Pretty much. And then we started seeing these milestones that really grabbed headlines.
Like Deep Blue beating Kasparov in chess. That was huge.
Absolutely huge. 1997 showed computers could handle incredibly complex strategy.
Yeah.
Then, 2011, you had IBM's Watson winning on Jeopardy.
Yeah, I remember that. That felt different. It was about understanding language, right? Not just chess moves.
Exactly. Watson had to understand the nuances, the puns, the context of natural language questions. A massive leap in natural language processing.
And then AlphaGo in 2016, beating the world Go champion. Go is supposed to be way more complex than chess.
Exponentially more complex, way more possible moves. It requires intuition almost. AlphaGo's win was stunning. It showed AI tackling immense complexity. And now, fast forward to the 2020s, we've got generative AI, tools like ChatGPT, DALE AI that can actually create stuff, text, images, music.
That really brought AI into the mainstream conversation, didn't it?
Absolutely. It's changed how we interact with machines and opened up totally new creative avenues. It's why AI is now seen as this transformative force across pretty much every industry. It's not just lab stuff anymore.
Okay, so we know what it is, we know the history, but how does it actually work under the hood? Let's get into the basics. The source points to machine learning as the key.
Yes, machine learning or ML. You hear the term all the time, and it really is the engine driving most modern AI.
So ML, break it down for us. What is it, simply put?
Okay, fundamentally, machine learning lets computers learn from data without needing explicit programming for every single task.
Right?
So instead of writing code for every possible scenario, ML systems look at data, find patterns, and then use those patterns to make predictions or decisions on new data they haven't seen before.
And the source mentions 3 steps. Get the data, train the model, test, and improve. Can you walk us through that, maybe with an example?
Sure, let's stick with the image idea.
Yeah.
Say we want an AI to recognize different dog breeds. First, you need data. Lots of pictures of dogs, crucially, labeled with the correct breed. Poodle, Labrador, whatever. And maybe images labeled not a dog. That's step 1, data collection.
Got it. Labeled pictures.
Step 2, training. You feed this labeled data into an ML algorithm. The algorithm crunches through the images looking for visual clues, patterns, features that distinguish a poodle from a Labrador, for example.
So it's learning the differences.
Exactly. Step 3, testing and improving. You show the trained model new dog pictures it hasn't seen during training. See how well it does. If it makes mistakes.
Which it probably will at first.
Oh, definitely. If it messes up, you tweak the algorithm, maybe give more data, and retrain it. It's this loop train, test, adjust, retrain until it gets accurate enough. Continuous improvement.
Okay, that makes sense. It's a learning cycle. Now, the source also mentions different types of machine learning.
That's right. 3 main types. First is supervised learning.
Supervised, like with a teacher.
Kind of. The supervisor is the labeled data. The AI learns from examples where the correct answer is already provided.
Like our dog picture or the spam filter. Emails marked.
Exactly. The AI learns the mapping between the input, the email, and the correct output. Spam, not spam. That's supervised learning.
Okay. What's next?
Next is unsupervised learning. Here, there are no labels.
No teacher this time.
Nope. The AI gets unlabeled data, and its job is to find hidden patterns or structures all on its own.
Like what?
Think about analyzing customer shopping data. An unsupervised algorithm could automatically group customers into different segments based on their buying habit, without being told beforehand what those segments might be, discovering patterns.
Ah, okay. Finding hidden groups. And the third type?
That's reinforcement learning. This one's a bit different. It's about learning through trial and error.
Trial and error.
Yeah. An AI agent interacts with an environment. It takes actions, And it gets feedback rewards for good actions, penalties for bad ones.
Like training a pet.
Sort of. Think about training a robot to walk, or teaching an AI to play a game like chess or Go. It learns the best strategy over time by trying things out and aiming to maximize its rewards.
Okay. Supervised, unsupervised, reinforcement. 3 different ways AI learns. And underlying all of them is data.
Absolutely critical. Data is the fuel, like the source says.
Yeah.
Without enough good data, AI just can't learn effectively.
And it's not just about how much data, right?
Right. The source highlights 3 key things. Quantity, yes, usually more data is better. Quality, the data needs to be clean, accurate, garbage in, garbage out.
Right.
And diversity of the data needs to represent the real world broadly. If your dog data only has pictures of Labradors, it won't be good at recognizing Chihuahuas. Diversity prevents bias and helps the AI work well in different situations.
Good quality representative data makes sense. And the source uses a music app example for how AI uses data to decide things.
Yeah, that's a great illustration. The app collects data on what you listen to, what you skip, what playlists you make.
Okay. My listening habits.
Right. It also looks at users with similar tastes to you, and it analyzes the songs themselves.
Yeah.
Genre, tempo, artists, things like that.
All that data.
Exactly. The AI algorithm processes all that, finds patterns in your preferences compared to others, and then recommends new music it thinks you'll like.
Pretty clever. Okay, so we've got the basics of how AI learns. Now the source talks about different kinds of AI, narrow, general, and super. What's the difference?
Understanding these categories is really helpful. It helps you sort the reality from the hype. First up is narrow AI.
Narrow AI, also called weak AI.
Exactly. And this is basically all the AI we have today, the AI we use every single day.
So Siri, Alexa, Netflix recommendations, Google Photos, finding pictures of my cat, all that stuff.
Yep. All examples of narrow AI. They're designed and trained for one specific task or a narrow set of tasks.
And they can be really good at that one task.
Incredibly good. But crucially, they operate within those limits. Your voice assistant is great for setting timers or playing music, but it can't, feel empathy or write a novel or understand context outside its programming.
So it doesn't understand in a human way. It just follows patterns in data for its specific.
Precisely. It lacks general cognitive abilities, consciousness, self-awareness. It's just very good pattern matching for its task. That's narrow AI.
Okay. Then what's general AI? Strong AI or AGI?
Right. Artificial general intelligence.
Yeah.
This is the theoretical next step. We're talking about AI with human-level cognitive abilities. Meaning it could learn, reason, understand, and apply its intelligence to any intellectual task that a human being could do. True adaptability and flexibility, like human intelligence.
Wow. Okay. And the key thing about general AI is?
It doesn't exist yet.
Right. Still firmly in the realm of research and development. It's a major goal, but we're not there.
Not even close, really. It's a huge scientific challenge.
Okay. And the third type, superintelligent.
Yeah, this one definitely sounds like sci-fi. Superintelligence is hypothetical AI that would surpass human intelligence across the board, not just in specific tasks, but in overall cognitive ability, creativity, wisdom, problem solving, everything.
So way beyond human capability.
Way beyond. The source rightly frames this as highly speculative, futuristic stuff, food for thought, but not something we're on the verge of creating.
So narrow AI is now, general AI is the future goal. Superintelligence is maybe way, way future, maybe never.
That's a good summary.
Why is it important for us, for you, the listener, to know these differences?
Well, it gives you perspective. It helps you appreciate what today's AI can actually do and, importantly, what it can't do.
Avoids getting carried away by the hype.
Exactly. It also helps you understand discussions about the future of AI, potential risks, regulation. It frames those conversations properly.
Yeah.
Knowing the difference between narrow AI and the hypothetical AGI is pretty fundamental to having an informed opinion.
Makes sense. Okay, let's ground ourselves back in the present. Narrow AI. We've touched on examples, but let's dive a bit deeper into where you actually encounter AI day to day. The source gives loads of examples.
It really is woven into the fabric of modern life now. We mentioned smart devices, voice assistants, smart thermostats, learning your schedule.
Yeah.
Those personalized experiences, shopping sites suggesting products, streaming services suggesting shows.
Definitely use those.
Productivity tools, too. Think grammar checkers, like Grammarly, smart replies in your email.
Yeah.
They're using AI to help you work faster or better.
Right. And you mentioned healthcare earlier. AI in diagnostics.
Yes, that's a huge area.
Yeah.
AI helping doctors analyze scans, identify potential issues, and safer transport driver assistance features in cars.
Yeah.
Like emergency braking or lane assist. That's AI.
It's also getting creative, isn't it?
Oh, yeah. AI art generators like DLE, AI music composition tools, AI helping with video editing, even in gaming. making characters seem more realistic or tailoring the game difficulty to you.
It's amazing how broad it is. The source even lists some really specific, ongoing research projects. Drug discovery, counting elephants from
Right. 3D holograms, pollution detection, even things like brain-computer interfaces translating thought to speech.
Wow.
Stroke recovery tech, fighting online misinformation, making robots with more realistic facial expression, diagnosing skin conditions from photos. The list just goes on. Driverless taxis, exploring molecules, improving telehealth.
It really highlights the sheer potential, doesn't it? The author even mentioned using AI for, like, YouTube subtitles, a personal time saver.
Yeah, a simple but practical example of how it can automate tedious tasks. It really drives home that AI isn't just this abstract concept. It has tangible benefit.
And for listeners who are thinking, okay, I want to try some of this out, the source actually lists specific tools.
It does, which is super helpful for getting started. It breaks them down into categories.
Like chatbots.
Yep. Mentions ChatGPT, Gemini, and also Perplexity AI, which is interesting because it cites its sources, good for fact-checking. The suggestion is, try ChatGPT to summarize an article or help brainstorm ideas.
Okay. What about images?
For images, DALE for generation, Canva AI has tools like Magic Design and Remove.bg for quickly taking out backgrounds. Easy ways to play with AI visuals.
Video.
Mentions Runway ML, Synthesia for AI avatars, maybe making an explainer video, and Pika Labs for text animation.
Cool. Audio.
11 Labs for realistic text-to-speech. You could try feeding it some text. Whisper for speech-to-text, and Voiceify for voice cloning. Lots to experiment with there.
And for coders.
GitHub Copilot, Codium, Tab9 are mentioned as AI assistants that help you write code faster. Could try Copilot for code completion.
Productivity.
Notion AI for writing help within Notion, and Microsoft Copilot integrated into Office apps. Listed is highlighted for helping summarize academic papers. Could be really useful for students or researchers.
And then there are just some fun ones.
Yeah, like this person does not exist, generates fake faces. Deep Nostalgia animates old photos, which can be quite uncanny. And AI Dungeon for text adventure. The source even suggests, like, generate a face, then use ChatGPT to write its backstory.
That's a neat idea.
The point is, there are loads of accessible tools now. Many don't need coding skills. It's a great way to just dive in and see what AI can do firsthand.
Definitely seems less intimidating when you see all these tools you can just try.
Exactly.
Okay, but we have to talk about the other side of the ethical concern. AI is powerful, but that power comes with risk.
Absolutely essential topic. The source does a good job balancing the potential for good healthcare, education, environment, accessibility with the very real challenges.
So let's talk about the bad first. What are the big concerns?
Well, a major one is bias. AI systems learn from data, and if that data reflects existing societal biases, the AI will learn and potentially amplify those biases.
Like the hiring algorithm example, where it might unfairly screen out.
Precisely. If the historical hiring data was biased, the AI learns that bias. Another big one is privacy. AI often needs vast amounts of data, sometimes personal data. Think about facial recognition being used for surveillance.
Yeah, that's a worry. And jobs, automation.
Job displacement is a significant concern. As AI gets better at automating tasks, certain jobs might become obsolete. Self-driving trucks replacing drivers is a classic example often discussed.
And the black box problem, not knowing how AI makes decisions.
Right, lack of transparency.
Yeah.
Sometimes even the developers don't fully understand the complex reasoning behind an AI's decision. Imagine being denied a loan by an AI and not knowing why. That's a problem.
So that's the bad. The source also mentions the ugly. What falls into that category?
This is where things get potentially more dangerous. Think misinformation and manipulation, AI generating fake news, deepfake videos or audio that are incredibly convincing.
Scary stuff.
Very. Also, autonomous weapons, AI, making life or death decisions on the battlefield without human intervention. Huge ethical dilemmas there. And just the risk of unintended consequences, complex AI systems interacting in ways we didn't predict, leading to negative outcomes.
So it's clear we need to be careful. How do we develop and use AI responsibly?
That's the million-dollar question. The source emphasizes the need for responsible AI development and deployment. It highlights key principles.
Like?
Fairness, avoiding bias. Transparency, understanding how decisions are made. Accountability, knowing who is responsible if something goes wrong. Privacy, protecting user data. Security, preventing malicious use. And ensuring AI systems are reliable and safe.
And it's not just on the developers, right?
No, it's a shared responsibility.
Okay.
Developers, businesses deploying AI, government setting regulations, and even us as users. We all have a role to play in ensuring AI is used ethically and benefits humanity.
Okay, wow. We have covered a ton of ground in this deep dive, from the basics, the history, how it works, the different types, all the examples.
Yeah, hopefully it's provided a really solid foundation based on the source material. And the key takeaway, I think, is that understanding AI isn't just for tech experts.
Right, it's becoming more accessible thanks to resources like the one we're discussing.
Exactly. Anyone can start learning.
So for you, the learner, listening right now, if you want to keep exploring this, what are some good next steps? The source had suggestions.
It did. Online courses are a great starting point. Places like Coursera, ADX, Udacity often have beginner-friendly AI courses.
Reading more.
Definitely. Lots of good introductory AI books out there. And like we said, trying things out, simple AI projects at home, playing with those no-code tools we mentioned, like Teachable Machine or TensorFlow Playground.
Getting hands-on.
Yeah, it really helps solidify the concepts. And maybe engage with the community, online forums, local meetups if they're available, talk to other people interested in AI.
It feels like getting a handle on AI is becoming, well, almost like a necessary skill for navigating the world.
I think that's fair to say. It empowers you to understand the tools you use, the news you read, and the changes happening around you.
Okay, so we'll leave you with a final thought to mull over, something to take away from the deep dive.
Considering how fast AI is evolving and how deeply it's becoming integrated into everything.
What specific part of AI are you most curious about digging into next? And thinking ahead, what impact do you imagine it might have either on your own life or maybe on the wider world?
Yeah, just something to reflect on as you continue your journey into understanding artificial intelligence.